In this video, I'm going to show you how to solve inequalities where something interesting happens. And in these examples, we're going to see the variables completely go away, and our answer is going to be no solution or infinitely many solutions. If you'd like to see a video on how to solve and graph inequalities that have solutions, click here to watch that video. So let's go ahead and get started. When we solve this first inequality, the first step we will need to do is distribute this -2. Now, some students incorrectly do 4 minus 2 and get 2 and then distribute that, but that would be using the incorrect order of operations. Instead, we want to use multiplication first by distributing in the -2. I would have 4 minus 2x minus 6 minus 12 is less than 6x minus 8x plus 9. Now on each side, I'm going to combine like terms. So on the left side, I will have -2x minus 14 is less than, and then on the right side, I will have -2x plus 9. Now, I can already see that these -2x's will cancel, but if we don't quite see that yet, I would think, all right, I'm going to add 2x to both sides, and then I see, sure enough, the variables do eliminate. That would leave me with -14 is less than 9. So here we have a special situation. My variables have eliminated, and I need to decide if this inequality is true or false. Is -14 less than 9? Since this inequality is true, your answer would be all real numbers. And again, this special situation happens when your variables eliminate and you end up with a true inequality. Now, what instead if this had been -14 is greater than 9? What if that's how the problem ended? Again, my variables eliminated, so I would ask myself, is -14 greater than 9? And the answer is, it is not. So if you get a situation where your variables eliminate and you get a false statement, your answer would be no solution. Let's take a look at another inequality. In solving this inequality, we will combine like terms on both sides. On the left, I have 4x minus 9. On the right side, when I combine 8x and -4x, I get 4x. And then also -5. I get the same exact thing on both sides. Now again, if you decided to continue and subtract 4x from both sides of the inequality, I'd be left with -5 is greater than or equal to -5. And like we did on the last example, I would ask myself, is this a true or false statement? Is -5 greater than or equal to -5? And because -5 is equal to -5, this is a true statement. And again, my answer would be all real numbers. And again, this is a special case that happens when your variables eliminate, and you need to ask yourself, is this a true or false statement? Now, what if instead this problem had been -5 is greater than -5? What if this problem started without the or equal to sign? Again, I need to ask myself, is this a true or false statement? Since -5 is not greater than -5 because they're equal, if this had been the situation instead, our answer would be no solution. Now, a common mistake I see is that what if this problem had been 4x minus 5 is greater than or equal to -4x? Let's keep it with the -5 as well. A lot of students look at this and think right away, this has to be all real numbers. But notice that this is a positive 4x and this is a -4x, so if you were to subtract 4x on both sides, your variables would not eliminate, which means you would be able to continue forward and solve this inequality. So just another reminder that in order to be one of these special cases, your variables do have to eliminate. All right, I hope you found this video useful. Make sure to click subscribe so that you're notified as weekly math videos come out. Have a great day, everyone.